So, good morning, students. Welcome in next lecture of Math F242 Operation Research. So, presently we are doing numerical examples on the different queuing models. We have covered 6 queuing models. So, first one is single server queuing model. Thereafter, we have the single server finite capacity queuing model. Then multi-server queuing model. Then we have multi-server finite capacity queuing model, self-service model, and last finite population model, multi-server finite population model. So in continuous of that, let us have this question. So I'm doing presently the question number 14, but you can practice with question number 16, 18, and 20. Factory has 4 machines. So when we have the this constraint, so you can presume that this is a question of finite population model. If we have this constraint, then you can presume that this is a finite population model. The time until breakdown, because we are talking about the machines, so we here instead of the arrival, we are taking that machines, we are taking breakdown. So time until breakdown of machine is exponentially distributed, means it is the entire arrival time, and here we have exponential distribution, so it is the m, and with mean 10 hours. With mean 10 hours means 1 upon lambda is given to you as a 10 10 hours, so lambda will become the point 1. The time to repair a machine has exponential distribution. Time to repair, because we are talking in terms of the breakdown, so here we are taking a repair time. Now repair time means instead of the service time, and it is given to you, this is also exponential distribution, so here we are writing the Markovian with mean 5 hours. So with mean 5 hours means 1 upon mu is given to you as a 5 hours, so mu will come zero point 0.2 per hour, zero point 0.2 per hour. Then after, a repairman cost is rupees 15. So this is the salary per hour. Whether he is he has to be paid whether busy or idle, whether he is providing the repair or not. But one has to pay, right, rupees 15 per hour. So this is the salary per hour. The cost of the lost time of a machine when inoperative is rupees 30 per hour. So first one is given to you as a service cost, and this is given to you as a waiting cost. If machine is not working, if machine is not functioning, right, so the factory has to bear this much waiting cost. Should the company employ one or two repairmen? So here the repairmen, number of repairmen, that is the S, is the decision variable. So what the policy you should opt, right, for which we have the minimum cost, for which we have the minimum cost. So what's the model? In this model, so first we have to decide whether the S is 1 or S is 2. That we have to decide, and it is given to you. There are 4 machines, means k is equal to 4. Lambda is given to you as a zero point 0.1 per hour, and mu is given to you as a zero point 0.2 per hour. This information we have. Now we have to decide whether we have the S is equal to 1 or S is equal to 2. So first we draw the transition diagram. So initially we have the 0 failed machine, thereafter we have the 1 failed machine, two failed machine, three failed machine. At most we can have four failed machine, right? Zero failed machine, one failed machine, two failed machine, three failed machine, and at most we have the four failed machine. Now, can you tell me what will be the rate for the finite population? Because there are the one machine is failing with the rate zero point 0.1. So the we have the four machines. So four machines will fail with the rate 4 lambda. Then 3 lambda, because now there are the three working machine. There are two working machine. Oh, okay, okay, 1 minute. This is the 4 lambda. 4 lambda, 3 lambda, 2 lambda, and this is the lambda. Here we have the 0, 1, 2, 3, 4. So here we have the 4 lambda, 3 lambda, 2 lambda, and here we have the lambda. If here we are taking the s is equal to 1, then service will be the mu, service is mu, service is mu, here the service is mu. When we take s is equal to 2, then the service will be the mu. Here we have the 2 mu, here we have the 2 mu, and here we have the 2 mu. Means number of server when increase, so here the rate will also increase. So when we have the two or more failed machines, then both repairmen will repair the failed machine. So from here C1 will come 4 lambda upon mu, C2 will come 4 lambda 3 lambda upon mu, and C3 will come 4 lambda 3 lambda 2 lambda upon mu, and C4 will come 4 lambda 3 lambda 2 lambda and lambda upon mu, 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 and mu. And thereafter Cn is equal to 0, because lambda is 0 there, for n greater than equal to 5. For n greater than equal to 5. For this case, C1 is equal to 4 lambda upon mu, C2 is equal to 4 lambda 3 lambda upon mu, 2 mu, C3 is equal to C3 is equal to 4 lambda 3 lambda 2 lambda upon mu, 2 mu, 2 mu, and C4 is equal to 4 lambda 3 lambda 2 lambda lambda upon mu, 2 mu, 2 mu, and 2 mu. From here we compute the P naught as 1 plus C1 plus C2 plus C3 plus C4 inverse. P naught here also we have the same 1 plus C1 plus C2 plus C3 plus C4 inverse. So from here, so from if you compute, so the value of P naught will come, value of the P naught will come 2 by 21, right? The value of the P naught will come 2 by 21. So here we compute, it is the 2 by 21. You can check, and value for the second model, here the it is coming I think there we have the mistake. So we have to compute. You please check what is coming. So it is the um, 2, 2. So this will be the 3 lambda power 4, 3 lambda to power 4 upon mu to power 4. This is so 6 lambda cube upon mu cube. This is 6 lambda square upon mu square and 4 lambda upon mu. And lambda upon mu is equal to rho. So rho is equal to what? Lambda upon mu, that is the 1 by 10 upon 1 by 5, that is the half. So it is the 4 into half. It is the 6 into half into half. It is 6 into half into half into half. And this is the 3 into half into half into half into half. So first one is the 2. So here we have the 1 plus 2. Second one is 3 by 2, 3 by 2. Third one is 3 by 4, 3 by 4. And this is the 3 by 16. So here we have the LCM inverse. So LCM is 16. So 16 plus 32 plus 24 plus 12 plus 3 inverse. So it will come. Please help me. 48, 52, 62, 72, 72, 74, 74, 84, 87. So it is the 16 upon 87. It is correct. Please check, verify. Please help me. It's correct. Anyone, please reply. Yes. So it is the 16 upon 87. So after having this, we can compute the P1 is equal to C1 P naught. So C1 P naught, here we have the 4 and half. This is the 12, half, half. So it is the 6, it is 3. So 3, it is 2, and it is 3. So it is 24 and 1 by 16. So this will come 3 by 2. So here the P1 will come. P1 is equal to, here C1 is 2. So no, 4 upon 21. P2 is, here the C2 is 3. So 6 upon 21. P3 is 3. So 6 upon 21. And P4 is 3 by 2. So 3 upon 21. Right? And Pn is equal to 0 for n greater than equal to 5. So that we have computed the PIs for the S server. Similarly, here the P1 will come, C1 is equal to 2. So 2 means 32 upon 87. P2 is equal to P2 is equal to, this is the 3, 3 by 2. So 3 by 2 means it 8 upon 29. Then we have 3 by 4. So 29 and 4. So 4 upon 29. 4 upon 29. And here the P4 is 3 by 16. So 1 upon 29. 1 upon 29. So now what we have to compute? What is the question? Question is how many servers, how many repairmen we have to opt so that total cost is minimum. So first we compute the total cost. So from here the total cost is what? Uh, salary, salary plus waiting cost, or service cost plus waiting cost. So salary per hour is given to you as 15. So it is given to you as a 15 plus 30 into number of failed server. Number of failed server. So expected total cost will become 15 plus 30 E of N. So that is the 15 plus 30 L. So here we
Sir,
have to compute. Yes,
sir, I think it should be 16 by 29. P2.
P2 is
So because the probability doesn't add up to 87. The 1 plus P naught plus P1. That.
P2. What you are saying? Please repeat. I'm not getting.
Sir, I think P2 is 16 by 29.
Uh, P2.
1 second, sir, I will calculate.
Huh? P2 is C1 C2 into 3 by 2 we are doing, na? So it is the 8 and it is the 29, na? 8 by 29 only.
Yes, sir, sorry, sir. Yes.
It's okay, no problem. So it is the 15 plus 30L. You can just check others. No, it may be calculation mistake. So what will be the L? L is equal to 1P1 plus 2P2 plus 3P3 plus 4P4. So all the value you have. Similarly, here also L is equal to 1P1 plus 2P2 plus 3P3 plus 4P4. So L will come for the first model. L is equal to 46 upon 21. So the cost will be the 15L plus 15S. 15S. So it is coming the 80.71. So in this case, for this model, expected total cost will come 15 for the one salary plus 30 into L. So it is the 15 plus 30 into 46 upon 21. Here the expected total cost will come 15 into 2. 15 into 2 you can write as a salary into S. Better you write as a S. So S, so 15 into 2 plus 30 into L. So here we can check what is the L. I think L is wrong here, right? So we have to compute. L is wrong here in this question. So can you tell me what is the L? P1 is equal to, please help me in calculation. 32 upon 87 plus 16 upon 29 plus 12 upon 29 plus 4 upon 29. Please help me. What will come? Yes, anyone, please give me the answer. It's 64 upon 29. It's the 64 upon 29. I have asked you always give the answer, always keep the answer in fraction only. So it is the 64 upon 29. Now you can give the answer this 30 plus around 64. So it is 80 point. It is the 80.71. It is the 80.71. Please give me this answer. 30 plus this. Now you can give in decimal. Please use the calculator. Give me the value. It's 96.20. It's 96.20. So here the expected total cost is less. So S is equal to 1, right? S is equal to 1, or one repairman is beneficial. So it is not necessary. Always we should go for the right multi-server model. It depends over what is the system. So most important here, I want to convey one important thing, that whenever we have the finite capacity or finite population model, always go with the worth and death process instead of applying the formula. I have already given to you formula also, but instead of applying the formula, you please one student has said that LCM is wrong. No problem, you change the answer. Here we are dealing with the concept. You change the answer. Give me the new answer.
Sir, why we didn't consider more than two servers?
Why didn't? Actually, they have asked only the between the s is equal to 1 and s is equal to 2. They have asked only for these two.
Okay, sir.
Ashwin, it is the cost 162.
Yes, sir. That's what total cost expected.
I think इतना नहीं होगा यार. Check करो. This much cost is coming. Okay, it's calculation part. You check yourself
No,
here, but
sir.
I want. Yes.
Sir, what will the value of L here? According to me, it is 128 by 87.
I think that is correct. It is the 128 by 87. With that, what is the cost?
74.1379.
74 point.
137.
ठीक. Right. So in that case, S is equal to 2. This is the correct answer. As per my recall, it is the correct answer. So all these are not correct. So here S is equal to two repairmen. So we can say here the two repairmen are beneficial. So in this chapter, we have to very much careful about the calculation. I always notice that people are not even able to compute the p naught. If p naught is wrong, complete question is wrong. Then we cannot provide even a single marks. If p naught is wrong, for any step we cannot provide any marks. So you have to take care in calculation of the p naught. So I was talking that whenever we have the question of finite capacity or finite population, always go with the birth and death process, right? Instead of using the big formulas, always go with the birth and death process. That will be the easy. If that capacity or that population is little large, then you can say that, then you can use the given formula. Now the last question. In this question, a man arrived at a barber shop in Poisa process at mean rate of 16 per hour. So it is given to you the inter-arrival time, follow the exponential distribution, that is the m, and lambda is equal to 16. The time taken for haircut is exponential distributed with mean of 15 minutes. So service time is given to you as exponential and mean is given to you 1 upon 16. 1 upon 15. 1 upon 15. So this implies mu is equal to 4 per hour. 4 per hour. Now the question is now important part is coming. The shop is staffed by two barbers. Shop is staffed by the two barber. That is the S is equal to 2, who are paid rupees 2 per hour. So salary is the rupees 2 per hour. Rupees 2 per hour each, and work 40 hours a week. So week time is the total week time is the 40 hours. So working hour is given to you as a 40 hours per week. Per week, when both barbers are busy but no customer are waiting, then one fourth of the customer arriving do not enter because they wish to avoid the waiting. Means if both server are busy, the customer shows the impatience behavior, and this type of the impatience behavior are known as the walking. After seeing that there is no space for the service, customer is not joining the system, right? These type of the impatience behavior are known as the walking. It means the one fourth of the customer, so only three fourth are joining, right? Three-fourth are joining. So here lambda 2 is what? Lambda 2 is 3 by 4 of lambda. When there are two customers, both are with both barber, means both are in service, At that time, the one fourth customers will not join the system. So actually joining rate will be the 3 by 4 lambda. That is important in this question. Then when one customer is waiting, it means 2 with varvar plus 1 is waiting. 1 is waiting, so lambda 3. Then 3 8 of the arriving do not enter the shop. It means only the 5 by 8 will join the system. Only the fraction 5 by 8 will join the system. Since there are only two chairs in which customer may wait, there are never more than two men waiting for the haircut. It means we have the, because of the finite capacity, it is given to you lambda n is equal to 0 for n greater than equal to 4. Greater than equal to 4. The shop charges rupees 2 for a haircut. So revenue is equal to 2 rupees haircut per haircut. Find steady state probabilities of the system. Find mean effective arrival rate of the customer who actually enter the shop. Find the average weekly profit of the shop. Is there any problem to understand the question? Anything you want to repeat? So this is the MM S is equal to 2, FCFS M is equal to 4, right? Infinity model, where lambda is given to you as 16. Lambda is 16 and mu is equal to 4. So from here we have, initially there is 0 customer, then 1 customer, then 2 customer, then 3 customer, and at most we can have the 4 customer. So arrival rate will be the 16. Arrival rate is 16, and here only 3 by 4 customer will join, so it will become the 12. And here 5 by 8 will join, uh, 5 by 8 will join, so it will be the 10. Clear? And there are the two barber, so they provide the service with the rate mu. When there are the two customers, so here the rate will become 8. Here the rate will become the 8, and here the rate will become the 8. So from this, the C1 will come 16 upon 4, C2 will come 16 upon 16, 4 into 8, C3 will come 16 16, 12 upon 4 into 8 into 8, and C4 will come 16 into 16 into 12 into 10 upon 4 into 8 into 8 into 8. So here we have the 4, here we have the 4, here we have the 2, here we have the 4, here we have the 2, and here we have the 8. So it's 12. Here we have the 4, it's 2, it's 8, and here we have the 6 4, then 3 2 then 5. So it's the 15. So P naught will be the P naught will be 1 plus C1 plus C2 plus C3 plus C4 inverse. So it is 1 plus 4 plus 8 plus 12 plus 15 inverse. So, it's 40. So it is the 1 upon 40. So when we have the 1 upon 40, so from here the P1 will come 4 upon 40, 4 upon 40, P2 will come 8 upon 40, P3 will come 12 upon 40, and P4 will come 15 upon 40, and P naught is 1 upon 40. Clear? So in this way, we have computed all the state probabilities, and Pn is equal to 0 for n greater than equal to 5. It is necessary to write. Thereafter, we have computed this. Find the steady state probability for the system. Find mean effective arrival rate of the customer which actually enter the shop. So mean effective arrival rate, that is the lambda bar. Lambda bar is what? Summation lambda n into Pn for n is equal to 0 to infinity. But for this case, it is the lambda 0 P0 plus lambda 1 P1 plus lambda 2 P2 plus lambda 3 P3, because lambda 4 and on and so on are 0. So it is the 16 P naught plus 16 P1 plus 12 P2 plus 10 P3. So 16 into 1 by 40 plus 16 into 4 by 40 plus 12 into 8 by 40 plus 10 into P3, 12 by 40. 12 by 40. So here effective arrival rate will come effective arrival rate will come 7.4. So it is the 7.4. You can see it is less than 16. So whenever we have the any type of the hindrance, always the arrival rate, effective arrival rate will be lesser than the actual one. These customers are actually joining the system. Then after, find the average weekly profit profit of the shop. Average weekly profit. So here first we compute the profit per hour, profit per hour. So what is the profit per hour? We have the we have to give the salary to two barbers. So 2 into s, that is the expenditure. So that we have to subtract. And from where you are getting the revenue? You are getting the revenue of rupees 2 from the served customer. Served customer, that is the mu bar. Just for explanation, I am writing here the mu bar. But you know that for the steady state, mu bar is equal to lambda bar. So here we have to write the 2 lambda bar minus 2s. 2 lambda bar minus 2s. So in exam, you have to write this only. Right? Just for explanation, I am writing this line. But you have to write this formula. Profit per hour is equal to expected profit per hour is equal to the 2 lambda var minus 2s. So it is 2 into 2 into 7.4 minus 2 into 2 into uh, 2 servers, 2 into 2 servers. So, and we know that if you have to compute the expected profit per week, per week, so this into 40, because it is given to you in a week, you have to work for the 40 hours. So that will come, that will come 432 rupees. So that's all for today, and that's all in the queuing system. In the evening class, I will start the new chapter, and that is very important chapter, right? Inventory. So please join that class. Well, in that class, I will give the basic terms of the inventory system. So anything you want to ask about this chapter? So most of that question we have covered. If you have any doubt, you can leave now. For today, that much.
Thank you, sir.
Welcome.